Hello, everyone. Happy to be here. So yeah, the topic of my talk today is kind of mass adoptions with private and asynchronous blockchains. But really what I want to talk about is that kind of the opposite of this is that there can be, like in my opinion, no mass adoption if you have either synchronous or transparent blockchains. And just to kind of set the context, and I'm sure everybody knows all of this already, but transparent blockchains, you really have, I guess animations will not work, but basically we have a bunch of nodes. And the block producer executes all the transactions in a block, and then all nodes have to re-execute the same transactions. And you can see like the state transition A and B. If there was an animation here, it would appear in one node, and then all the nodes would execute those. And because of that, all nodes need to keep track of the entire state. So to execute transactions, to execute them, you need to have the state to execute the data. So kind of the problem that creates in my mind is that really mass adoption of Web3 and crypto is not really possible if you have transparent blockchains. And there are three reasons for why it is not possible. And here, the first reason is about scalability. And this includes both execution, kind of re-executing transactions, but it also includes state. Like frequently people talk about like bottlenecks that happen in execution. Can you execute transactions fast enough? But there is also obviously state bloat that you need to keep track of all the state to be able to execute those transactions. The second problem is privacy. And by the way, I'll dive into this in more detail in the following slides. With transparent blockchains, by definition, there is no real privacy. And I'll explain like why this is a problem. And then similarly, like one of the big problems with blockchains because of their irrevocable nature is like safety. And what I mean by that is that like, you can have bugs in smart contracts, people can get compromised in many ways. And in the transparent blockchains, bugs are very easy to detect because everybody sees the code, and they're also very easy to exploit. And this leads to very undesirable consequences. So unless we can address all of this, we're kind of like, in my opinion, will not get to scalability, will not get to mass adoption. And so let's go into this like one by one. So for scalability, what do we mean by this? And here I'm imagining a world where crypto is really adopted. It's not like right now we're at a very, very nascent state. So like you can imagine things like 10 billion accounts overall. Like every person has an account, and even more than one account, maybe multiple accounts per person for various reasons. You have at least 100K TPS, but probably much, much more. And you don't do just simple transfers. Like there are complex transactions that involve like smart wallets and other things. It's basically you can imagine the entire like asset exchange of the world lives on blockchains. And those blockchains, and this is an important thing, are censorship resistant. This is the core property because we can build this in a non-censorship resistant way very, very easily, but we want to build it in a censorship resistant way. So can we get to the scalability? And there are really three aspects to this. So let's talk about state. If you have 10 billion accounts, and then let's say every account requires 400 bytes. You need, 400 bytes because you own some number of tokens and whatnot. So like in Ethereum, for example, every token that you own adds 32 bytes to the state. So 400 bytes like you own like 10 different types of tokens. Not talking even about NFTs or anything of that sort. So you get to like 4 terabyte state. If you now say we own much more, so like, let's say concert tickets and everything else is represented as assets on the blockchain, now you're talking about 40 terabyte state. And, arguably 40 terabyte state is a lot, and I don't know if you can maintain it in a censorship resistant way or in a network that is not like super centralized. We can talk about execution as well. So like, for example, to process 100,000 transactions, you need 10 billion gas if every transaction is 100K gas. And this is like current average transaction. Like I'm not talking about simple transfers, which like I think 20K gas roughly. If your transactions become more complicated, like DeFi transactions, or like if you need smart wallets that do all kinds of like rate limiting or different types of signatures and things like that, you can imagine gas requirements being higher per transaction. So you actually go to much, much higher, 30 billion gas per second. And that's way beyond the current capabilities, although like rollups help with that. And then there is bandwidth in terms of how much data can you put on the blockchain. So like if you assume something very simple, about 10 megabytes per second. If you assume like the state where you have much more usage and all of that stuff, then you like 60 megabytes per second. I think Ethereum in in a long-term roadmap, but I don't remember exactly, but it's something like, I believe like 1.2 megabytes per second. Like that's kind of where we think we'll have amount of bandwidth of DA on Ethereum. Privacy. So why is this a problem? So in my opinion, there can be no mass adoption without real privacy. And the reason for this is like, with Web 2, at least we have some form of privacy. We can say that our transaction histories are not fully private. Our like banks know about them, PayPal knows about them, whatever, but the entire world doesn't know about them. If we get to the point where blockchains are mass adapted to like the scale that I described before, and there is no privacy, we'd create a dystopia where everybody's entire history is basically known and traceable for the entire world. And this is, I would argue, a situation much worse than the Web 2 situation today. So I think we probably don't want to build something like that. You cannot get privacy without off-chain execution. And this is where ZK comes in. Like you need to be able to execute things off-chain, and I'll talk about specifically about off-chain execution in a second. And then you also, if you keep all this track of all the state, the privacy becomes expensive. And that's a problem because if privacy is expensive, you incentivize people to shy away from privacy on one end. So they don't use it as frequently, then they kind of incentivize not to be private, but also it incentivizes people who may want to do something illicit to be private. So you kind of like misalign incentives a little bit. And safety, as I mentioned, like in a transparent blockchain, vulnerabilities are very easy to detect, identify, they're very easy to exploit. I compare this situation to a situation where you have a computer connected to an internet without firewall or any kind of protection. This is the world where we are right now. You identify the bug, you can exploit it very easily. There's an alternative to this, and I will talk about kind of like if you have, let's say, state off-chain, it's kind of a computer that is disconnected from the internet, and it's much more difficult to exploit those vulnerabilities. But also like transparent blockchains, at least up to now, they tend to have like this unsafe designs in some way where you have honeypot contracts that control a ton of assets, and like exploiting one contract in a single transaction, you can steal a ton of funds. Like ideally, we don't want to create honeypot contracts to make this exploitations, even if the bug is found, is much, much more difficult. So I guess, what is the solution to this? And like one of the things that I would argue about, is that solution is to move things, both state and execution, to the client side. And if you think about different ways to how blockchains execute transactions, so like there is sequential execution that we know, let's say Ethereum executes transactions one after another, and in this case the block producer is the one who executes them. You have parallel execution as well, where still block producer executes the transactions, in this case, you can do them in parallel, and that scales a bit better. You can also try to scale Ethereum with this using block STM and other approaches. But I think like we can push it a bit more forward and get to a point where we have client-side execution improving. And this means that users execute transactions themselves on the client, on their devices, on your smartphone, in your wallet, or whatever, on your laptop. You execute transaction, you prove it, and then you just send the proof to the network. And this is where ZKPs come in. And once you send the proof to the network can verify that, and you get a ton of positive properties because of that. For one, you don't need to re-execute transactions. You don't need to execute them in the first place, so the complexity of the transaction almost doesn't matter to the network. But also you keep the state on the client side, and that reduces the state bloat and other things. So let me go through kind of like the computation aspect of it. So the original blockchain model is that all transactions go directly to L1, and L1 executes them. In a rollup model, transactions are batched and proven by L2. So you kind of move computation, kind of shard computation a little bit, and then you just send the proof to Ethereum or another L1, and you send the state delta, or you can compress transactions, and so on and so forth. And then with client-side proving, you actually push this to the user again. So like the users do those execution proofs, and then they send it to L2. So you kind of basically make every user a kind of like a roll-up, so to say, because the same thing as was being done by an L2 now is being done by every user. If we talk about the data aspect of this, the original model, all data goes to L1. In a roll-up model, you still need to put data on L1 because you need to be able to reconstruct the state, but you can do some compressions. There is different ways to make it, improve on this aspect. There is also a validity mode where you can actually say, okay, I'm going to put the proof on L1, but there's going to be an alternative DA that was going to handle the state deltas or whatever. And then in the client-side model, you can actually put the data with the user. In many cases, doesn't work in 100% of cases, but in most cases, you can put the data with the user, like your wallet keeps track of your account state. It requires the redesign of how you think about the state. Like in Polygon Miden, our state model is very different from Ethereum. But you can kind of like push the state so where, for example, every account requires only 40 bytes, regardless of the complexity of the account, how much code you have, how much storage you have, how many assets you own. It will always require only 40 bytes of storage on the main chain, on a L2 chain, and then the L2 chain can push it down to L1 chain. So we get to this we want to get to this point where we have both a situation where both computation, is residing at the client side, and users execute and prove most transactions. And I'm saying most transactions because there are some transactions that still need to be executed by the network, specifically anything that touches shared state. And this cannot be executed locally because there can be concurrent state updates and there will be conflicts. But you can actually say that in most cases, like 95 maybe more % of situations, you don't actually need to, like if I'm sending money to somebody and making a transaction, you don't need to touch a share state. Like we only need to touch our state, I need to touch my state, and then you need to update your wallet or whatever. And then the data is stored locally with the user, as I mentioned, and that gives us both privacy, because if you store the data locally, it doesn't need to be shared with the network. But it also gives us scalability because, again, you reduce state bloat dramatically. And kind of to expand a little bit on this idea, it's actually like it's not one way or the other. You can mix and match things in a very interesting ways. And this is kind of like the model of Polygon Miden as well, where you can have, let's say, on-chain data, off-chain data, network execution, and local execution. And you can say, for example, if you have on-chain data in network execution, meaning the network executes transaction for you and the data lives on the chain, that means that you get a regular public transaction. And those transactions are useful in many, many situations. But if you say, okay, I'm going to have off-chain data, but I'm still going to execute the transaction on the network, so I'm going to, every time I need a transaction, I'll send the data required for the transaction to the chain, you get kind of like the stateless transactions. Now, if you do execution locally and you store data locally, you get private transactions. And this is very important, as I mentioned, for privacy reasons, for safety reasons, for efficiency reasons, and so on and so forth. And then, like, to complete this on-chain data but local execution, this is a very interesting use case because, for example, you want the data to be, it's a shared state, you want it to be accessible, but let's say your smart contract is super, super complicated. You require like a data center worth of computation to run because like it's some kind of ML model inference. It will never fit into a block on Ethereum or anywhere else, like it's too complex. But if you can do local execution, you're limited only by your own hardware. You can actually execute billions of gas in a single transaction, prove it, and then submit it to the chain or to the network. And the network, from the network standpoint, verifying the correctness of this transaction is almost as simple as verifying the correctness of a simple transfer. So you get this unbounded scalability, both in terms of, like, in this case, in terms of computation. If you take the state off chain, you get unbounded scalability in terms of computation and state as well. So I think, again, like, to achieve mass adoption, I think we really need to get to the kind of like improve on these three properties of scalability, privacy, and safety. And with client-side proving and client-side state, you get kind of like kill three birds with one stone, because you get safety, because it's very difficult to exploit bugs if your state is local, even if there is a bug that is found. You get privacy by default because you execute and store things on your client, and you also get unbounded scalability because you don't burden the network with the computation it doesn't need to run, and you don't burden it with a state that it doesn't need to keep. Thank you.
Thanks, Bobbin. Any questions? I have one question.
Sure.
So on the last slide, you mentioned there are 4 options.
Yes.
For state and execution. I believe the current the mainstream mode is the public transactions. But for like mass adoption or the new trend, which option you think will gonna be the new trend?
I think it really depends on the use case, because I think like if we're just regular people transacting with each other, most of that should probably be private transactions. But there are some situations where you may want to have public transactions where, for example, you want to do like a DEX type of thing where then you need to have a shared state between people. You can still hide like who is interacting with the DEX, like it's a very cool approach, so you don't know who is trading with whom, but you still need to see the amounts and kind of like the trades itself. So like for that you would use public transactions. As I mentioned, like the local transactions with the public data still could be useful where you want to retain like a property where, for example, if your whoever's executing this code goes away, you still want somebody else to be able to execute this, because if they keep the state locally, there are some issues with that, could be depending on how you structure it. So I think all 4 have use cases. Is the question like what are you going to use them for? I think the majority of transactions would be private transactions, but there would be like some transactions that like fall into every category.
Thank you. Okay. Thank you, Bobbin.
Thank you.